Hello everyone, welcome back to Year 10 Mathematics. My name is Victor, and today we are going to be covering surface areas of cones and spheres. Now in Year 9, we found the surface area of prisms by drawing nets. But you actually can't draw a flat net of a sphere. It's curved in every direction. So for complex curved objects like cones and spheres right here, we're going to rely on formulas. Which is going to be very obvious because we have been relying on formulas for calculating surface areas and volumes for shapes anyways. So we'll just do that again. So we have a sphere. It doesn't look like a sphere. It is a circle. It's a 2D circle, yes, but we're going to use formulas to calculate hypothetical sphere. So as you can see right here, I'm going to write the following. SA equals 4 pi multiplied by r squared, radius squared. So the only measurement here that we need is the radius, the distance from the center to the edge, as you can see right there. So it is around 4 times or so the area of a flat circle with the same radius. So the problem here would be something like you need to find the surface area of a sphere with a radius of 5, right? So you want to write the formula first. It's a channel classic, of course. Always write the formula first, and then just plug and play. And then plug and play, when I mean plug and play, I mean by substituting. So 4 times p times 5 squared, and 5 squared is going to be 25, of course. So 4 times 25 is going to be 100. And the exact answer is going to be 100 pi. And that in that calculator, it should be equal to 314.16 square meters. That's for our sphere right there. But what about for the cone? Looks pretty complex. There are more sides and edges now. So think of an ice cream cone with a flat lid on it. It has two parts, the circular base off the bottom and the curved sweeping side right here. So we're going to write the formula as usual. We have SA, which is the surface area, equals the area of the base plus the area of the curved side. And we are going to write it out in the form of this, basically. Because it's the area of the circle and then area of the curved side right here. There you go. We have the base is the circle, so pi r squared. The formula for the curved side is pi times the radius and times s for the curved side here. And actually, when you're asking about what is s, really, s is actually the slant height and what you want to do is you want to differentiate between the true height and the slant height. The true height h here, as you can see in the middle, is the true height dropping straight down the middle. S is the slant height, which is the length for the angled edge down the outside here. So the surface area formula uses the slanted edge, S. And the problem would be something to find the surface area of a radius of 3 and a slant height of 7 or something like that. And so we just need to plug and play, substitute them on together because we know the variables. We know what is r, what is s, and possibly even know what is h as well. And even if we don't know what is s, we can easily find s using Pythagoras. We have r, h here, so r squared equals h squared equals s squared, because if you look very closely, this is actually a right triangle. So even if you only know r and h, you can easily find s. But let's just say in this case, we do have s. So we just need to substitute them together. We have pi times 3 squared, which is give us 9 pi. And then we have pi times 3 times 7, which is going to give us 21 pi, and that's going to give us 30 pi. And that should be on our calculator 94.25 units. Or square units, I should say, so sorry. Okay, so that should be it for more. So these lessons for formulas is just gonna be me saying you to like write the formula first and then to distinguish certain things that may trap you. That's really it, because shapes rely entirely on formulas. So always write the formula first to guide your substitutions, plugging and playing. And for cones, be very careful, of course, as usual. Okay, I'll see you next time where we will not calculate the surface area, but we'll calculate the volume. Thanks for watching.